Before we can use a t-distribution for inference about a single mean, we need to check two conditions. First, hopefully it's one you're familiar with by now, but independence of observations. The second is observations come from a nearly normal distribution. Now, the second condition is partly about sample size, but it's also about the how well it looks as a normal distribution. Anyway, we can verify independence as we've done before. Either we collect a simple random sample from less than 10% of the population, or if the data are from an experiment or random process, we check the observations were randomly assigned to a treatment and control groups. That is, we're looking for random selection or random assignment. The second condition can be difficult to verify for small data sets. For larger data sets, like over 30, we can be pretty certain that things are going to work. But for small data sets, what we can do is we can look at a plot of the data for obvious departures from the normal model. That is, we can look for outliers. And second, we can compute z-scores for the minimum and maximum values and check to see that whether either one is beyond -3 or +3. Now, this nearly normal condition can be relaxed as the sample size increases. For instance, if your sample size is at least 30 or more, then it's okay to have a little bit of skewness or some moderate outliers. If your sample size is 60 or more, then it's okay if you have some strong skew or even larger outliers. Essentially, the more skewed it is, the larger the sample size needs to be. The larger the sample size you have, the less that this condition matters. Okay, for example, New York is known as the city that never sleeps. A random sample, so random, sample of 25 New Yorkers were asked how much sleep they get per night. And statistical summaries of these data are shown below. So let's check the conditions to determine if a t-distribution is appropriate to use to answer whether New Yorkers sleep more or less than 8 hours of sleep, a night on average. Well, for independence, we're told random sample, 25 New Yorkers, so independence looks good. So the sample is randomly selected, so we can assume independence. In terms of normality, we have to look at the minimum, z-scores for the minimum and z-scores for the maximum. So the z-score for the minimum would be, I take the 6.17, I would subtract off the mean of 7.76, and then divide by the standard deviation. So I would go parentheses 6.17 minus the mean of 7.76 divided by the sample size, standard deviation, of 0.77. And I get negative 2.076. Or negative 2.06. The maximum, again, maximum is the same. Same setup, except they use the maximum value of 9.78 minus the mean of 7.76 divided by the standard deviation. And you can try it yourself. You should get like 2.62. Just kind of a note that the z-score, the minimum is always going to have a negative z-score. The maximum is always going to have a positive z-score. Because the minimum is always below average, the maximum is always above average. Anyway, neither scores beyond 3 or -3, so we can assume normality. So we've checked independence, we've checked normality. The conditions for inference seem to have been met.